Here's problem 31.6. A rectangular loop, area of 0.15 square meters, turns in a uniform magnetic field with the magnetic field equal to 0.2 Tesla. At an instant where the angle between the magnetic field and the normal to the plane of the loop is pi over 2 radians, and increasing at the rate of 0.6 radians per second, what is the magnitude of the EMF induced in the loop? Alright, so we just have one loop. So our N is one turn. And the area of this loop is given as 0.15 square meters. But it's turning, so it might be turning around like this in a magnetic field. Magnetic field is equal to 0.2 Tesla. So in general, our flux is going to be equal to, for a planar area like this, would be the field times the area times the cosine of the angle between the area vector and the magnetic field. Well, that angle is constantly changing. So let's use the full Faraday's law on this. The induced EMF will be equal to the negative number of turns times the derivative of the flux with respect to time, or the change of the flux in an infinitesimal amount of time. So I could write this as negative number of turns, change of field times area cosine theta per time. Theta is the only thing that's really changing here, so we can take the field and the area out of this derivative, and so our induced voltage, EMF, will be equal to the negative number of turns times the field times the area times the derivative of the cosine of theta. So as a negative number of turns, field, area, and that will give me negative sine theta d theta dt by the chain rule, the change in theta with respect to time. So this will be number of turns, field, area, sine theta d theta dt. Alright, we have one turn. Our magnetic field is 0.2 Tesla. Our area is 0.15 square meters. We're going to evaluate this at the point where theta is equal to pi over 2. And at that point, it's increasing at the rate of 0.6 radians per second. So that's our change in theta with respect to time. So putting all this in here, realizing that the sine of pi over 2 is 1, we have 0.2 times 0.15 times 0.6, 0.018 volts. So that is our induced EMF at that moment where theta is equal to pi over 2 or 90 degrees. We have a magnitude of the EMF is 0.018 volts.